Hello and welcome to another exam paper walkthrough. I've got something a little bit different planned for this session. This is obviously GCSE maths, but I'm going to be looking at an AQA predicted topic paper. I'll explain a bit more about what I mean by predicted topic paper, but this is taken and preparing for the June 25 paper 1H. Attached to the description to this video, you will find a link to a Google Drive where you can download a copy of the paper if you've not already done so. I would strongly recommend that you do the paper either before or alongside the video, just to get the most out of it. I'd also recommend a bit of music on in the background. When I record these videos, I will always have some music on, so I find it a lot more enjoyable. If you find this video useful, please do subscribe if you like, and you will get the notifications as soon as any other videos get uploaded onto my YouTube site. Before I really get into the video, I'll discuss briefly what I mean by a predicted topic paper. So I've gone and done an analysis over all of the new 9 to 1 paper ones for hire that have appeared so far, and I've done a percentage of appearances. And then I've just focused on the most common topics, and I've built a paper using an AQA question level analysis and facilitation outline to produce a paper. This is the outline of all the topics, and then what I've done is, after I'd selected my my total for the paper, what I did was I arranged them initially by questions facilitated by grade at the grade 9. I went from easiest to most complicated. All the ones that are in red at the moment are questions that are spread over, so they've got more than one part. And then I've just kind of, once I'd got those topics, I chose and placed them based on their national facility, which is why this circles question is an interesting one, because technically by the national facility percentage, it came out as the hardest, but actually on the grade 9 students, it wasn't their worst. But you can see how that's kind of an anomaly. That was just so that the question built in level the difficulty. The other one that's worth a slight mention is this standard form part A and part B were actually split as two separate questions, but I've put them next to each other, and you'll see as it hits how that's worked out. Other than that, this gives you rough grade boundaries for the paper, which is quite useful. These have kind of been truncated. It's a good example of truncation, so I've hidden the decimal points. So you can kind of assume that you need the next one above, just to give you an idea of how many marks you need for those grades. Right, that's set aside. We shall get on with the paper. Okay, so here's the paper. Let's get into it. So question 1, factorise x squared plus 2x minus 24. So we're going to factorise that. That means put into brackets. So we're going to have two brackets. To make the x squared coefficient, both brackets must start with an x. And then we're after two numbers that multiply together to make the back term. So two numbers that multiply together to make minus 24, which tells us one is negative and one is positive. And they need to add together to make plus 2. Which tells us that they need to have a difference of 2, and the positive one needs to be larger. So we're going to go 6 and minus 4, 6 and minus 4. So x plus 6 and x minus 4. Let's put it on the answer line. Make it as easy as we can for our markers. Okay, question 2. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their age is 5. How old is Joel? Right, so I'm going to go, I'm going to kind of create a bit of a ratio table to help me out here to J. So I'm going to call X there. Beth is 1 year younger, so that's going to be X minus 1. And Joel is double, so 2x. So the mean of their age is 5. So there's 3 of them. So that means that the sum of their ages must be 5 times by 3. So that's going to be 15. So the sum of these, so if I add these 3 parts together, that's going to give me 4x minus 1 is equal to 15. So I now want to solve that. So I'm going to add 1 to both sides. So 4x is going to be equal to 16. Divide by 4, x is going to be equal to 4. That's not quite what we're asked though. Joel's age is 2x. So 2 times 8, there's 2 times 4, which would give us an age of 8. Oh, that's quite a generous 5-mark question. Okay, question 3, circle the value of cos 30. Tricky one to remember, but cos 30 is going to be root 3 over 2. If you're struggling with that, nice quick way of, well, not quick way, if you did it from principles, if you imagine a 2 by 2 by 2 triangle, we cut it there, very badly drawn. So you imagine we had a 2 by 2 by 2, we cut it there, that would be 1, and this length here would be root 3, this angle here would be 30. Cos 30 then is 30, well, cos is equal to adjacent over the hypotenuse, which in this case would be root 3 over 2. Adjacent next to, hypotenuse 2. Okay, question 4, solve. So to solve this, what I'm going to do is I'm going to times 3 by 15. Because 15 is 5 is a factor of 15, so that will get rid of both my denominators. So 2w divided by 15 times 15 would just give me 2w, and then 4/5 times by 15, well, the 5 and the 15 would simplify to 3, would be equal to 12. And then if I divide both sides by 2, that would be w is equal to 6. Okay, question 5. Simplify in the form n to 1. Okay, so if we keep it in the ratio form for now, what I'm going to do is I'm going to convert, let's say this one, no. What I'm going to do is I'm going to convert this one to being a 10 to the minus 1. So to do that, I would need to make this number 4 times bigger, so that would be 2000 times 10 to the minus 1 to 5 times 10 to the minus 1. So then I'm going to I've gone way too complicated on this. Let's change that around completely. What I'm going to do is convert them to being normal numbers. I've just realized that would be much more simple. So that's going to be 2000 to 0.5. Then double them both would become 4000 to 1. So 4000 to 1. Okay, question 6. Solve. So this is another example of factorising to start with. So I'm going to say that that's going to be both starting with x and then, like before, two numbers that multiply together to make minus 12 and that add together to make minus 1. So again, one is negative and it is one bigger than the other one. So I'm looking at 4 and 3. This time the bigger one is the negative. So plus 3 and minus 4. Now, for two things to multiply together to make 0, one of them has to be equal to 0. So either x plus 3 is equal to 0 or x minus 4 is equal to 0, which gives me the solution either x is equal to minus 3 or x is going to be equal to 4. Okay, question 7. Billy wants to buy these tickets for a show. 4 adults at £15 each, 2 children at £10 each. 10% booking fee is added to the ticket price. 3% is then added for paying by credit card. Work out the total charge for these tickets when paying by credit card. Okay, so I'm going to want to do 4 times by 15 plus 2 times by 10, and I want to times that by, in effect, 1.13. 10% booking fee is added to the ticket price. 3% is then added, so I've done that slightly wrong. Times by 1.1 and then times by 1.03. So I'm not obviously going to do that. I'm going to work out this price first of all. So we're going to go 4 times by 15 is going to give us £60 plus £20 times by 1.1 and then times by 1.03. And I'm not going to do this multiplication. So that's going to be £80 times by 1.1, then times by 1.03. So 10% of 80 would be 8, so that's going to be 88 times by 1.03. Right, so I'm going to do the 3% separately. So I'm going to say if 100% is 88, then 1% would be 0.88. So 3% would be times that by 3, which would give us 24, and then 24 again would give us £2.64. So I want to add that to my 88, which is going to give me £90.64. I'll show that as well though. So I want to do 88 plus £2.64. There we go. Okay, question 8. Solve. So to solve this, I'm going to start by timesing 3 by 3 to get rid of this fraction here. So that's going to give me x plus 15 going to be equal to 6 lots of x plus 10. I'm going to multiply out my brackets, so x plus 15 is going to be equal to 6x plus 60. That's very good x. Right, I'm then going to minus x from both sides, so that's going to give me 15 is equal to 5x plus 60. I'm then going to minus 60 from both sides, so that's going to be minus 45 is equal to 5x. I'm then going to divide both sides by 5, so minus 9 is equal to x. So x is equal to minus 9. Okay, write the number 6,005,200 in standard form. So let's write it numbers first. 6,005,200. 6,005,000. You should say and 200 really. So 6,005,200 in standard form. So that's going to be 6.0052 times 10 to the 6. Okay, question 10, we've got y is inversely proportional to x, complete the table. So if y is inversely proportional to x, I quite like doing it this way. So here we're timesing by 2. So if it's inversely proportional here, we'd need to divide by 2. So that would be 2. And then here, to get from here to here, we're timesing by 2. So here we would divide by 2. So that would be 3. Okay, question 11. Density is equal to mass divided by volume. The mass of solid A is 3 times the mass of solid B. The volume of solid A is 3 times the volume of solid B. Complete the sentence. The density of solid A is blank. The density of solid B. Okay, so I'm going to call the mass X and Y just to help me out here. So the density of A then. So the mass of solid A is 6 times the density of solid of solid B. So the mass, that would be 3x over, if we assume the same volume for now. And then it says the volume of solid A is 3 times the mass, 3 times the volume of solid B. So I'm kind of overly complicating this, I think. Carry on. If I actually call this density B, so the density of A is 6 times, not 3 times. 6 times the mass of solid B, and then the volume of solid A is 3 times. So that means overall the density is going to be 2 times the density of solid B. Okay. Part B. Average speed is equal to distance divided by time. If the distance is halved and the time is doubled, what happens to the average speed? So we've got to imagine that's been times by a half, and then that's been times, the distance is halved, and the time is doubled. So I think that's going to be, well, I don't think that's going to be the same as dividing by 4. Because this is, if I carried this through, that's going to be equal to distance divided by, that was half, sorry, distance over 4 times the time, which is equal to distance divided by time divided by 4. So divided by 4. Okay, question 12. The nth term of a sequence is n multiplied by n minus 4, close bracket, divided by the square root of n plus 3. Work out the sum of the first and the 6th term. Okay, so I think we've just got to substitute in our values. So this is going to be 6 times by 6 minus 4, all divided by the square root of 4 plus 6, 6 plus 3, quite nice, plus the first term, which is going to be 1 times by 1 minus 4, divided by the square root of 1 plus 3. So that's going to be 2, so that's going to be 12 over 3 plus minus 3 divided by 2. Let me just check that. That's definitely 2. That's definitely, yeah. So that's going to become 4 minus 3 over 2, or 1.5. So that's going to be 2.5, or 2.5. Okay, question 13. Circle the fraction that is equivalent to 4.625. Okay. So I'm going to discredit this one and this one, because that would have to be a multiple of 0.25. So it's got to be one of these two. And then if we look at how many times it goes into, well, let's say 8 times by 4 is equal to 36. Try that again, 32. So 0.625 is going to either be equal to then 7 over 8, or 5 over 8. And it's 5 over 8. We can do the division if we want to. So 8 divided into 5.000. So it won't go in fully there. So we've got 5 left over. And then 8s go fully into 50. 6 times with 2 left over. 8s go fully into 2 with 4 left over. Goes in fully 5. So we're looking at that 37 over 8. Okay, question 14. Here is the speed time graph for a 50-second journey. Okay, circle the acceleration in meters per second halfway through the journey. So halfway through the journey would be 25, and we've got a speed, but it's constant speed, so that would be 0. Work out the distance travelled. Well, the distance travelled is going to be the area. So it's going to be equal to the area of the trapezium, which is going to be a half of A, which would be 30 plus 50 times by the height, so times by 20. Okay, so that's going to be a half of 80, which would be 40, times by 20, which is going to give me 800 meters. There we go. Right, question 15, factorize. Okay, so factorising quadratics where we've got a non-monic or a value that's not 1. It can be tricky. However, 5 is a prime number, so it's got to go into 5x and x. So we can follow that same principle as before. We're looking for two numbers that multiply together to make -8. And because of this 5 lots of one of the number plus the other number add together to make 6. So one of them's got to be negative again. Right, so we could have 4 and 2. How would that work? So 10, and yeah, that would work. So 5 times 2 would be 10, and then -4. Right, and then if you think about how you multiply this out, the 2's got to go in the bracket opposite the 5. So we're looking at that. So 5x minus 4 multiplied by x plus 2. Okay, part B, simplify fully. Okay, so we've got two quadratics. We've got a difference of 2 squares on the bottom, which is the first bit that I'm going to do because that will give us a hint for the top line. So x plus 2 times x minus 2. And then our top line. So for it to simplify, one of these two brackets has got to be up here, but because we've got no negatives here, we can automatically say that it's got to be x plus 2, which would mean the other bracket would need to be x plus 7. And then we simplify by cancelling those two terms. So that leaves us with, it's as simple as it goes, x plus 7 over x. And I've crossed out my wrong thing there. Over x minus 2. Okay, question 16. The table shows information about 10 people, times for 10 people to complete a task. And then these statements are about the mean and the range for actual times. Right. Tick the correct box for each statement. So I'm not a massive fan of these questions. They can take quite a lot of time to explain. So I will do my best, though, obviously. Right. So to help me explain this, I'm going to either say that these, depending on which question we're doing, I'm going to either take these frequencies to be the smallest or the biggest. For the smallest, technically it's got to be bigger than 0, but I'm going to use 0 just to help me explain. Right, so the mean could be less than 20. So let's work out the very smallest that the mean could possibly be. So assuming that that was 0, We're going to use 0 there. 3 lots of 20 would be 6 lots of 20 would be 120, and 3 lots of 40 would also be 120. So that would be a total of 240. Divided by 10, that would be the very smallest it could be would be 24. So that one's got to be false. The mean could not be less than 20. The mean could be more than 40 minutes. Well, I'm certain that that one's going to be true. But again, if I talk about the maximum that the mean could be, so the maximum we could have is 20 there. 6 lots of 40 would be 240. And then 6 lots of 3 lots of 60 would be 180, which would give us 200, 400, 440. So the maximum the mean could be 440. So yes, it could be less, could be more than 40. It could be less than 40. We should have ticked that one last time. We had got the maximum that it could be 240. So we already know that that one's true. I should have ticked that when I was there. The range. Okay, so the range is slightly easier to work out. So the range could be more than 40 minutes. So the range could be more than 40 minutes. Let's assume that that was 0, and then let's take the biggest value of 60. So the range could be 60. So the range could be more than 40. The range could be less than 40. The range could be less than 40. So for that, if we imagine that that one was 20, and we imagine that, so the largest one there, and then the smallest one in this bracket, let's say, was 40. So the range could be 20. So the range could be less than 40. The range could be more than 60. We've already done that one here. That one would be false. So that's how I would go for that. False, true, 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 false. Okay, question 17, work out. So a bit of surds here, or a bit of, yeah, we'll treat, I'm trying to work out if to rationalize the denominator straight away, because obviously I'm going to have to eventually. I'm going to do it afterwards to save having to rationalize it twice. So I'm going to say that that's going to be 7 root 3 over root 20. Then I'm going to rationalize the denominator by timesing through by root 20 over root 20. We could, I'm going to, just in my mind thinking, should I simplify this surd first? I'm going to simplify it afterwards. So that's going to give me 7 root 60 over 20. And then if we rationalize the denominator, I'll do it over here. Root 60 is going to be equal to the square root of 4 times by 15. So that's going to be 2 root 15. So if root 60 is 2 root 15, then 7 root 60 is going to be 14 root 15 divided by 20. And then we can simplify by a factor of 2. So I'm going to go 7 root 15 over 10. Okay, question 18. The triangle cross-section of a prism is an isosceles right-angled triangle. The volume of the prism is 102 centimeters cubed. Use approximations to estimate the value of x. Okay, so we're given that value there. Right, so the volume, to find the value of x. So first of all, I'm going to work out the cross-sectional area using an approximation. So the volume of a prism is equal to the cross-sectional area. So I've got area times by the height, or the length. Length is probably better to use there. Right, so if I'm using approximation, I'm going to say that 102 is approximately equal to 100, and my other value is going to be 8.14 is approximately equal to 8. Right, so I'm going to say that 100 is going to be equal to the area times by 8. So if I divide both sides by 8, then I get that the area is going to be equal to 100 over 8 is the same as 50 over 4, which is 25 over 2. And I'm going to leave it like that for now. I'm not going to go decimal on this. So the area of a triangle is equal to... the area of a triangle is equal to a half base times height. So in this case, we're looking at a half of x times x, or a half of x squared. There's my pen working again. A half of x times x. So I'm going to call it a half of x squared. Right, and these two areas are equal. So I'm going to cancel out a half and say that x squared is equal to 25. Meaning that technically we've got plus or minus 5 as our answer here. However, we can't really have a negative length, so I'm going to go 5 centimeters for x. Okay, question 19. In a box, there are some buttons. 45 are large and the rest are small. Some are yellow, the rest are green. The number of small is 5/3 of the number of large. The number of green is 300% the number of yellow. There are 12 small yellow buttons. How many large green buttons are there? That's the actual figure that we're after. Okay, so the number of small buttons is 5/3 the number of large buttons. So I'm trying to work out whether to put it in the table. Here we go. So we know that there are 45 large buttons. So if we know that the number of small buttons is 5/3 the number of large buttons, so I'm going to do 45 times by 5 over 3, which is going to be 15 times by 5. So 15 times by 5, which is going to give us 75. Just checking my work in there. Yeah, 75. Right. So from there, the number of green buttons. Okay. So I can work out the number of small green buttons. So I'm going to have 75 minus 12, which is going to give us 63 here. The number of green buttons. Just looking for one other piece. Okay, right, yes. So what I'm going to say is I'm going to say the number of green buttons is 300 times the number, 300% the number of yellow buttons. So if I say that yellow is x, then green would be 3x. And that's the key bit that we were missing. So we know then that the total for both of these is 45 plus 75. So that's going to be 120. So in terms of this, 120 is going to be equal to 4x. So x is going to be equal to 30. So that means that we would have 30 here and 90 here. So from there, we can jump straight to our actual goal, which is going to be 90 minus 63, which is going to be 27. It's not particularly needed, but we can also double check that we're right here. This will help me out a little bit as well. So if that must be 30 and we've got 12 there, that must leave 18 there, but does that work here as well? So 18 plus 27 is equal to 45. So I know I've got that 4 marks there. That's a good way of double checking. Okay, question 20. 4 times sine 30 times sine 30 times cos 30 is equal to sine y. Work out one possible value of y. You must show your working. Okay, so I'm going to rely on the I've drawn that incredibly badly. So I'm going to rely on the equilateral triangle split in half. Equilateral triangle that was 2 by 2, so that's half of that. So that would be root 3. And my 30-degree angle then is hitting here. I've not drawn that particularly well. That's going to be my 60. Right, so that's going to help me just to work out my 3 values here. So we're going to be looking at 4 times by sine of 30, which is opposite over hypotenuse, so it's going to be a half, times by tan 30, which is opposite 1 over root 3, or root 3 over 3, times by cos 30, which is going to be root 2 over. It's going to be root 3 over 2. So getting ahead of myself there, root 3 over 2. Right, so I'm going to straight away cancel that, and that. So that's going to give me root 3 times root 3 divided by 3, which is going to be 3 over 3, which is going to give me 1. Yeah, so one possible value, 1. Oh, no, sorry. So that's my value of sine y. So sine y is going to be equal to 1. Which means that if we think about the sine graph, so the sine graph starts at 0, so we could go for 90. Well, 90 is going to be the most common one. We could also go for 360 plus 90. We could also go for 90 minus 360. But 90 is going to be the one that I would expect most students to go for. Okay, question 21. Rearrange y is equal to 5x plus 9 divided by x to make x the subject. So my first step is I'm going to multiply both sides by x, so that would give me yx is equal to 5x plus 9. I'm then going to take all my x coefficients to one side and everything else to the other. So that would give me yx minus 5x is equal to 9. I'm then going to factorise by taking x out as a common factor. So that's y minus 5 is equal to 9. I'm then going to divide both sides by this bracket. So x is going to be equal to 9 divided by y minus 5. Rearrange to make x the subject. So x is equal to 9 divided by y minus 5. Okay, question 22. Here are the first 4 terms of an arithmetic sequence. Find an expression for the nth term. So if I look at the first sets of differences, so the first set of difference there is 15. Then we're looking at 19. Then we're looking at 23. Second set of differences, then we've got 2, and then we've got 4. So that's going to imply that we've got an n squared in term. So the way I'm going to do this is I'm going to write down my 4 terms, 11, 26, 45, and 68. Underneath it, I'm going to write down n squared. So that would be 1, 4, 9, and 16. Then I'm going to look at the difference. So I'm going to do the sequence minus n squared. So that's going to give me a difference of 10, a difference of 12, a difference of and I've made a mistake here. That difference, 26 take away 4 is 22. And then my next difference is 36. And then the difference here is going to be 54, I think. And I've just spotted I made a silly mistake. Let's try this again. My first difference was 4. Difference between 19 and 15 was 4, which means that I've got a 2n squared in there. So 2n squared. So that should have been 2 times 1 is 2, 2 times 4 is 8, 2 times 9 is 18, and then 2 times 16 is 32. Right, so difference between those two numbers now is going to be 9. Difference between those two numbers is going to be 18. Difference between those two numbers is going to be 27. Difference between these two numbers is 36. And then these are going up in 9s. Well, this is just the 9 times 2. So this sequence is just 9n. The 9n would be 9, 18, 9 times 3, 27, 9 times 4, 36. So my sequence is going to be 2n squared plus 2n squared plus 9n. Okay, question 23. A times 10 to the n is a number in standard form. Complete the inequality to find the value of a. So a has got to be greater than or equal to 1 but less than 10. And the second part, originally on the original paper that I picked this question from, this was a part A and a part B. Just to bear that in mind. Okay, question 24. B times 10 to the n is the number 2,700 written in standard form. Work at B times 10 to the minus n, give your answer as an ordinary number. Okay, so if we write this in standard form to start with, that's going to be 7.2 times 10 to the 3. So we want the value of 7.2 times 10 to the minus 3, which would be 0.0072. Okay, question 25. Here is a list of 11 whole numbers in numerical order. The lower quartile, the median, the upper quartile, and the highest value are missing. The median is equal to 2 times the lower quartile. The upper quartile is 2.5 times the lower quartile. And the range is 2 times the interquartile range. Complete the list. Okay, right. So I'm going to call this value x, and then the median is 2 times the lower quartile, so that would be 2x. And then the upper quartile is 2.5 times the lower quartile. So that is going to be 2.5x. 2.5x. And the range is 2 times the interquartile range. So the interquartile range is going to be equal to 1.5x. Then the range is going to be equal to has got to be equal to 2 times the interquartile range, so it's got to be equal to 3x minus 5. Okay, so I'm going to start doing kind of a little bit of trial and improvement. So, we've only got an option of, we've got more than whole numbers in numerical order. Okay, so this value can only be 8, 9, 10, 11, 12, 13. And it can't be 8, it can't be 9. The reason being, for 2x, obviously 2x has got to be bigger than 19 but less than 25. So if it was 8, 8 times 2 is 16, so it can't be 8. So x can't be 8. Could it be 9? So 9 times 2 would be 18, so it'd still be too small. So it could be, let's say 10 to start with. So if it was 10, 20 would work there. 2.5 times by 10 would give us 25, so that is a possibility. Let's try 11. We might come back to that in a second. So 11 times by 2 would be 22. We can't do 2.5 times 11 and get a whole number. Let's try 12 then. 12 times by 4 would be 24, which could still work. And then 24 times by 2.5 would be 18. So it's got to be either be 10 or 12. And then let's look at the next part then. So what I'm going to do is I'm going to put 10 there and 12 there, which means that would be 20 or that would be 24. And then this one would be 25 or so that wouldn't work, would it? Actually, that wouldn't work. So it can't be 25 because 25 is less than that. So the value has got to be 12 because obviously 13 wouldn't work because that would give us 26. So we've got to have 12. We've got to have 24. We've got to have 30. But we haven't got our final one. So our final one, the range is 2.5 times the interquartile range. So let's take these out and put in those values. So we've got 12 and 20. So we've got 12 there, we've got 24 there, and then we've got 30 there. And then our final one, the interquartile range at the moment is 12, take away 30. So the interquartile range is 18. And if the range is 2 times the interquartile range, the range has got to be equal to 36. So 36 take away 5 is going to be 36 plus 5. No, I'm going silly here. So the range has got to be 36. So the range has got to be 36. So the maximum value has got to be 36 plus 5, which will give us 41. Okay, question 26. P, Q, and R are points on the circle. SP is a tangent to the circle. RQ is equal to PQ. Prove that. Okay. Okay, so first of all, I'm going to say that that angle must be equal to y. So uh, RPQ must equal y, as it is base angle of an isosceles triangle. Isosceles triangle equal. I'm then going to say that this here is going to be 2x. So RQP must be equal to 2x. And that is the alternate segment theorem. And then based on that, I can say that 2x plus y must be equal to 180. And it's angles in a triangle, angle sum a triangle is 180 degrees. So based on that, I can say that, let's tidy it up a little bit, 2x plus 2y must be equal to 180. If I halve everything, that would give me x plus y must be equal to 90. And then if I rearrange to make y the subject, that would be y is equal to 90 minus x, which is what we were asked to show. Okay, question 27. A coin is thrown 50 times. It lands on heads 30 times. Write down the relative frequency that it lands on heads. So that would be 31 out of 50. So I'm sure that would be absolutely fine. Alternatively, you could give that as a decimal. So that would be 62 over 100, so 0.62 would also be fine. Right to say, if the coin is biased towards heads, use the data to give a reason why he might be correct. So we could discuss. We would expect the relative frequency to be 0.5. Well, we wouldn't really expect that. So we would expect. So I'm gonna expect 25 heads. 25 heads. 31 is greater. Anything along those lines. Okay, question 28. Three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum for the original three numbers. Okay, so let's add some context to this. So three whole numbers, let's call them A, B, and C. A plus B plus C is equal to 10. Work out the maximum possible sum for the original three values. So the three values could have been rounded. So each one of these numbers rounded to the nearest whole number could actually be 4 bigger. So we could have had an A plus 4 plus B plus 4 plus C plus 4, because they're all whole numbers, and if it was 5 bigger, it would have been rounded up. And that was 70. So if we add 4 to all of them, we'd have 12 bigger, so 70 plus 12. So we're looking at 82 there. Okay, question 29. A journey has two stages. Show the average speed for the whole journey in kilometers per hour is 2ab divided by a plus b. Okay, so I've just done a lesson on compound measures with my year 11s. So we didn't go into this advanced, but right. Average speed for the whole journey. So the average speed, we need the total distance. So the total distance is going to be 60. And then the total time for it would be these two added together. So the total time would be, let's do 30 over A plus 30 over B. So we need to put them over the same denominator of AB. So that would give us 30B plus 30A. Right, so the total time is going to be, well, factorize it slightly, 30 lots of A plus B over AB. So the average speed for the whole journey then is going to be equal to, speed is equal to distance divided by time, which is going to be equal to 60 divided by, so I'm going to do it like this rather than doing it as a fraction. It's not very often I do it like this. 30 divided by 30 times by A plus B divided by AB. Right, so when we divide by a fraction, it is the equivalent of multiplying by its reciprocal. So AB over 30 A plus B. So 60 divided by 30 would be 2, so that's 2AB divided by A plus B. There we go. And that's what we asked to show. So that works out quite nice. Nice question. Okay, question 30. 15 machines work at the same rate. Together, the 15 machines can complete an order in 8 hours. 3 other machines break down after working for 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work? Okay, so if 15, I'm going to try and show this as easily as I can. So 15 machines working for 8 hours gives us a combined total of 15 times by 8, which will give us 40, 120 worked hours. Right, 3 of the machines break down after working for 6 hours. So that means that we had 15 times by, no, not 15, yeah, 15 times by 6. So we had a total of, that's 90. So we had a total of 90 worked hours. Meaning that we've got 30 left. And now we're doing that between 12 machines. So we want to do 30 divided by the 12 machines to get our time. So that's going to be the same as, we can cancel down by a factor of 6, but 6. So that would go 5 and 2. So that's going to be 2.5 hours. And I've just realised that 2.5 isn't, strictly speaking, the answer. So I was just reading, in total, how many hours does each of the other machines work for? It's 2.5 extra hours. So that's not our answer. So our answer is the 2.5, 2.5 plus the 5 hours that they'd already been, 6 hours that they'd already been working for. So that's 8.5 hours. So 8.5. 2.5 is the number of extra hours. How many hours does each of the other machines work for? So the 12 that work full without breaking down work for 8.5 hours each. Okay, question 31. A, B, C are points on a circle. X squared plus y squared equals 36 as shown. A is on the y-axis. B is on the x-axis. M is the midpoint of AB. COM is a straight line. COM is a straight line. Show that the coordinates of A are 0, 6. Okay, so x squared plus y squared is equal to 36. So if it's on the y-axis, x is equal to 0. So 0 squared plus y squared equals 36. So y is equal to plus or minus 6, and a is on the positive axis. So a has to be equal to 0, 6. Work out the coordinate of B. So same process applies here. B would be at the coordinate where where y is 0 and x is 6. Part C, show that the equation of the straight line passing through C, O, and M is y is equal to x. Okay, so if we take the we could find the coordinate of M. So if M is the midpoint, M must be the midpoint of must be 0 plus 6 divided by 2, comma 6 plus 0 divided by 2, which is going to be equal to 3, comma 3. Show that the equation of the line is through 0. So we've got two coordinates on there. We've got 0, comma 0, and we've got 3, comma 3 now. So that's the origin, and that's the midpoint. Quite clearly that's the line y is equal to x. Do I think that's enough? Strictly speaking, no. Y, the gradient, yeah, let's do it. The gradient between those 2 points, is going to be equal to 3 divided by 3, which would be equal to 1. So y is going to be equal to 1x plus c. And if we plug in this coordinate, c is equal to 0, so y must be equal to x. I think I've gone more than I needed to there, but we'll give it as that. Okay, work out the coordinate of c, giving it in third form. Right, if the intersection of y equals x and x squared plus y squared equals 36. Okay, so based on that, I'm going to say y squared equals x squared. So we're actually looking at, let's say, 2x squared is equal to 36. So x squared is going to be equal to 18. So x has got to be equal to the square root of 18, or plus or minus the square root of 18, which is going to be 3 root 2. So x has got to be equal to plus or minus 3 root 2. we're looking at the negative version there. So for C, we're going to have minus 3 root 2 and minus 3 root 2. And that brings us to the end of the paper. Right, before I sign off, I'm just going to bring up the Q&A again.